Okay. All right. Hello, everyone. So usually people ask, the presenters ask the audience to put their phones away. I would like to ask you to pick your phone right now. You have to pick it out of your pocket. And go to this URL. There is no phishing, no scam, no IP address collection, no botnet, no whatever. It's a game, and I would like you to play with me. Wow, this is fabulous. People are using my software.
It's gray and white, not black and white.
Oh. I think it's a projector, but whatever.
Yeah, of course.
Okay, any success? Success, okay. You will see it in the next slide as well. So please use this URL, keep it open on your phones. It will change automatically during the presentation, and we will. It's a public. No, it's a public address. Yeah, it's not Nokia internal. Yeah. All right. So let's start. So thank you for the introduction. Mistral is the workflow engine of OpenStack. And a workflow, according to Wikipedia, is an orchestrated and repeatable pattern of business activity. Of course, this is just a small excerpt of a huge wiki page. But in my opinion, or for me, usually a workflow is just a couple of dots and links between them, which define a process. I almost forgot to mention that whenever you see that brain in the corner, you should look at your phone, and it will change. All right. So what are the main objectives of a workflow system? First, it defines a language. It's distributed. It provides parallelism and data flow between the activities it describes. It provides you APIs to create and delete workflows and do whatever you want, monitor the state, and most importantly, oh, it disappeared. Was it me? No. Okay. And most importantly, it provides a persistent state. What does persistent state mean? Persistent state means that you can observe the progress, you can observe the execution histories, you can execute your workflows asynchronously and do recoveries or what. It doesn't work. It died. Okay, it's overwhelmed a little bit. Whatever. We will just not use it. The alternative that we usually use for workflows is scripting. Scripting is fabulous. I love scripting. I usually just go to the bash console and curl something if I have to do an API request, or SAD if I have to change something in a file, which is working fabulously as long as nothing goes wrong. As soon as something goes wrong, I have to do the error checking, I have to do the whatever. I have to, sorry? Yeah, I have to check the logs, whatever I have to do. And the other thing is that scripting is not scalable. When you have to provision thousands of servers, it's not possible to run just scripts. So it's not suitable for large-scale orchestration. Mistral provides you a workflow language that you can use to describe the workflows. It's YAML-based, and it relies on expression languages like YACL, which is the expression language defined by OpenStack, and Jinja, and there may be others in the near future. And of course, it provides all the constructs that you're familiar with from general programming. The building blocks or the entities in Mistral are the workflows, the tasks. Workflows are composed from tasks, and tasks use or execute actions. There is a definition pane and there is an execution pane, and not all entities have an execution correspondent. Only workflows, tasks, and actions have execution parts. And the execution is the persistent state that I was talking about, that you can use to review the history of your execution. And there are some other useful entities that we will talk about later. Here's an example workflow. It has a name. It's composed of tasks. For example, this one is lists some VMs, and then the other one deletes those. It has a connection between those tasks, and we will go into detail about how it is composed. So as I said, the actions are the one-by-one building blocks of workflows. The actions are the simplest kind of functions that that execute your business functionality. There are some standard ones like echoing, sending an email, doing an HTTP request, or SSHing somewhere. And of course, as Mistral is an OpenStack project, it has integrations with many other OpenStack services. Going on with the constructs, with the programming constructs, of course, the language provides you conditional transitions. You can decide when to use which, or when to go through which link between the tasks. Here, for example, we go to the send report, or we execute the send report task only if the number of VMs we returned or listed is more than 0. The next one is publishing. Whenever a task is finished, it can publish values. In this case, it publishes the list of VMs. And these expressions are the ones I mentioned from the beginning. These are YACL expressions. The next construct is fork joining. Of course, you can do this. You can, if you define a join, you can say that you want to wait for all incoming links, or you want to wait for just 1 or 2 or 3, whatever number you can imagine, or whatever number is possible. Of course, there are loops. If someone is familiar with Ansible, we also have this with items construct. And we have some engine commands like failing, succeeding, or pausing the whole workflow for a while. Before the execution or after the execution of tasks, you can define additional behaviors. For example, if it fails, you want to retry. You want to wait a bit before or after, or you want to time out the whole task if it doesn't complete in a given time. And of course, you can nest the workflows. It's very simple. You just define that the action of the task is going to be a workflow, define the name of the workflow, the input parameters, and you're done. One of the neat constructs in Mistral is the cron triggers. The cron triggers is actually resembles a cron tab that is implemented in the cloud. And by nature, it comes as a highly available service, and it runs the workflows according to the defined cron patterns, and you can define other attributes as well. If you are interested in the DSL, you can go to this link and you will find the details there. Now let's go down to the details. Why we are here. It is numbers. And we are absolutely fond of numbers nowadays. We love big data. We collect everything we can ever imagine. Memory, CPU, I/O. You can define KPIs in whatever ways you want. And we measure everything. And we want to make predictions or just assess the current state of the system. In case of Mistral, we thought that measuring the performance, reliability, scalability aspects of this project or service is very important. And we came up with a couple of dimensions that you can create your tests from. So for example, you can consider the number of tasks. You can consider the length of the sequence of the tasks, short or long. You can consider the parallelism, even on task or workflow levels. And I think it took a little while to come up with this list, but at the end we were able to kind of Lego together synthetic tests that would target a very specific facet of the service, and it was really useful for us. How is Mistral constructed? It has an API service, and the API service is an N-active redundancy. It has an N-active redundancy model. You can run any number of it, and it will serve your requests in a round-robin fashion, if not defined otherwise. Then there is the engine that does the heavy lifting of running your workflow, and it is persisting the state of the workflow to the database. And there are the executors that execute the actual actions. And all these are connected through RabbitMQ and use some kind of DB. It can be MySQL or Postgres. During our tests, I wanted to find ways to kind of assess how Mistral performs, and I decided that I will go through all these layers, and I started with the API. Of course, because it's the easiest to test, because it has a REST API, you can use it to do CRUD operations on Mistral entities. You can use it to initiate the workflows, and it was the first facet that was interesting for us. Initial stats, just a few numbers. The memory per instance or per process that initially is consumed by every Mistral API process is just about 70 megabytes. But of course, this can go up as the time goes on. And a very neat thing I found, and what I wasn't aware of, actually, is that it uses socket-based load balancing. I don't know if anyone is familiar with the POSIX sockets here, but the Mistral API processes fork themselves, and then every child process goes to the accept phase. And then it is the kernel that decides which process is going to take the incoming connection. And I think this is a very neat solution. If we want to test REST APIs, one of the tools you can use is JMeter. It's a very stable, long existing project or application. It's very useful. The tests we created or I created were creating executions, listing, traversing the API, and I was interested in the responsiveness of the of the API and load distribution and those kind of stuff. Here are some data again with different sizes of workflow sets. So for example, with 100 workflows, the creation takes about 6.5, or not the creation takes, you can create 6.5 workflows per second, and the listing is going to be about 30 requests per second. With 1,000, it goes down to 3 per second. With 7,000, it goes down. It doesn't change actually, but the amount of data is going to be huge. And in the last column, you can see the difference it makes if you use the limit parameters that limits the number of returned entities. And this suggests us that we should never actually do the just give me everything kind of listings, but always use the limits. And it may be useful if we just imposed these limits automatically in the API as well. The next service was the engine that I looked at. Its functions are the heavy lifting, the workflow processing, and managing the data flow between the tasks, persisting the data, reading it from the database, and it does the input-output calculations and runs the expressions as well. Here, one of the important aspects is the size of the data that is transferred between the tasks, because, for example, if you execute something that returns data, or one of the results is going to be a huge amount of data, this is going to be transferred back to the engine and then transferred down to the next executor. And in some cases, this can take so long that it's prohibiting to do. And for this reason, recently there has been a change in the project, and now the engine can execute actions as well, not just the executor. Just an example of how the input-output calculations are done. This is an excerpt from the previous examples, and these are the expressions that are run by the engine. And then the last one is the executor. It's very simple, just the actions run here. It takes the RPC request from the engine, does the work, and then responds. As simple as it can be. Of course, we did some long-running tests, and here are the data for that. It was running for about a week. It included 50 cron triggers that ran every minute, so about 50 runs per minute, which in total was about 500,000 runs at the end of the week. And the run was targeting the creation and stopping of Docker containers, because that was important in our case. So the test was to create or start a dedicated container that was dedicated for a given trigger, touch a few files, clean up the files, and then stop the container. And here's the data that we gathered from this test. There is a little skew here in the timeline, so please forgive me, I wasn't able to fix it so fast. The upper diagram is the system load, and the lower diagram is the amount of data transfer to the disk. And what we can see is that in the ramp-up phase, the disk operations just steadily go up. It peaks at about 40 or 60 megabytes per second. And the system load was, oh, what is this? And the system, oh my God, I messed it up. You should never push K. Whatever it is. It's here. Ah, fantastic. So initially, the system load was okay, and everything was fine. Here, I thought that something is messed up with my test because the executions were not as fast as I expected. So in theory, I should have gotten about 50 executions per minute, and I got much less, like 30 or 25s. And I was interested in why, and actually it was the flavor. It was caused by the flavor. It was too small, so I resized it. This is the time I resized this flavor to 16 gigabytes and whatever disk it was, and then I let it to run. And it ran for 6 more days, and it was interesting to see that as the Docker operations take a lot of I/O, and the disk and the kernel got saturated for some reason, the system load became really chaotic. The transfer data was lowered, of course, because of the collisions. And at the end, I decided to terminate the test, and we can see that the system load and the data transfer went down. What this suggests, actually, for Mistral, because this is mostly talking about how Docker performs in the long run. But for Mistral, what we can see is that the data transfer is practically zero, and the system load is really small, which means the service stayed very steady, or it was very stable, which was a really good outcome for us, actually. And it ensured that we can use this service in our product. Some war stories, because these are always interesting. And I think these are the most interesting parts of presentations. And there was an interesting case about sometime last summer when we started to use Mistral very heavily. And we started to run big workflows, like 300, 400 tasks in a single run. And we saw that it was very, very slow. After some optimizations, we got it down to from like 15 minutes down to 5 minutes of execution. And it was a great achievement. And to celebrate it, a rally job was created that ensures that we do not introduce such kind of errors in the near future or in the future at all. Another interesting story was the usage of expressions. We again saw that the execution was really slow. And we were using big data, like 50, 60 megabytes of data. And the selection process took really long. At the end, we figured out that YACL was the cause of the issues, and the Jinja was significantly faster, like 5, 6 times faster. So in the end, we went to the YACL guys and provided them with ideas how to improve their solutions. And now it seems like YACL and Jinja are on par. Connecting to this, we tried big data, and we changed this parameter, the execution field size limit. And we throw it up to like 100 megabytes, and we expected to see 100 megabyte documents being transferred from one test to the other. We used MySQL as the database, and it turned out that we also have to change MySQL's maximum allow package size to be able to transfer this kind of data. And the last one is, again, a performance issue. When we saw that the database was crashing, we were running a long test, like, I don't know exactly, about a week or so, and we saw that the Mistral was consuming lots of CPU, it's not me. Lots of CPU, the database was trashing, and at the end it turned out that we accumulated about 40 or 60,000 executions, and there was a policy that tried to clean this up, but in a single transaction. And now you can imagine what happens if you want to delete tens of thousands of entities from a database in one transaction that is already under heavy load. It of course is going to time out, and everything is going to be rolled back, and it will try again. So we came up with a solution, and now if you set the maximum executions, the number of maximum executions you want to keep in the database, it is going to work just fine. Let's go to some demos, because those are always interesting as well. This is not the official GUI of Mistral. This is something I created for myself and to all you. And, but I think it's a really useful tool. So just to give you an idea of what kind of workflows we implemented, here's one of the workflows. The details are not important, actually. It's just the size and the type of constructs we use. In this workflow, we have tasks, we have a nested workflow, and lots of parallelly executed tasks. In this workflow, we have lots of embedded workflows. I think it's me. It's probably me. Okay. I will just step here, like so. Well, it's going to be bad, so let's try it another way. Okay. Let's create a new workflow. This workflow just generates some inputs and does processing, and then it loops around. This is the definition. And in this neat GUI I created, I can run it. Let's submit the stuff. Fabulous, it's running. Okay. Oh, broken pipe, great. And here we can see that the Mistral server is working. In theory, this should stop, but it doesn't. Oh my God, what is happening here? Let's see the tasks. Oh my God, we have lots of task executions and lots of action executions, I guess, as well. Yes. And it is growing. So what can we do now? We are going to take the ID of this execution and give it to sh, just to be really descriptive. Oh, and it does the magic. It cancels the workflow, and in theory, it should be canceled. We should not see more tasks coming up here, and should not see more action executions. And one of the neat features is that you can clean up the mess that was created by an execution by just a simple click. I put, yeah, and now everything is gone. If you delete the execution, everything is going to be deleted in a cascaded fashion. Okay, let's do some more interesting stuff. Here I have a workbook. A workbook is actually just a container for lots of workflows. It's not very useful after it's created, but it's useful for creating new workflows. And here I have tons of example workflows. These are the ones that we actually run in production. Very similar or very simple ones. Let's try this one. Let's say the size of the data that is going to be transferred between tasks is 10, and the number of handovers is 12. Submit, it's running, and it succeeds. Great. Let's go back, delete everything. And I will, oh, not this one. I will show you an embedded workflow as well. It's sub workflows. Oh my God, what's going on? Oh, it's here, yes. Oh, this one is a workbook as well, yes. So we have this workflow. It does a very similar thing as the previous one, but it loops on creating new nested workflows. If we run it, the size of the data is going to be something small, number of sub-workflows is going to be 2, nesting level, which means how deep you go in this tree, is going to be 2 again, and data is, it should not be set. It's just something that is required. And here, what we can see is that the tasks are generated one by one, and for every execution, these are the workflow executions. For every nested workflow execution, you are going to get a new workflow execution entity in the database. And you can create it, delete it with one click. So in conclusion, I just would like to mention a few quotes from the last summit that I went to, which was in Boston. And I heard quite encouraging idea, or quite encouraging news about Mistral. The first one was, can I use Mistral to implement VM expiration policy? So if you have a big cloud where you want to delete VMs that existed for a given time, the answer is, of course you can. There was a question about if they could use it in OOO to again clean up some stuff. Of course you can, and they said the cron job feature is a killer feature. And one of the new services in OpenStack is the Masakari, which is something related to containers, because everything is container now. And they also said that they wanted to use Mistral to call some workflows to execute some kind of actions. And this came up in an OpenStack high availability discussion, actually. So all in all, I can tell you that Mistral is production ready in some sense. It's me. It's production ready in some sense. We use it in production. We rely on it. We contribute the resources to develop it, and it's really, really useful for running workflows in the cloud or everywhere, or anywhere you want. Thank you.
Thank you very much. Do we have any questions?
Why did the application fail? Oh my God. Yes, it really did fail. Oh, fabulous. Thank you, Amazon.
At least there are 0 no's. So.
Yeah, the idea was that we would review this page and we would see how. So, how many of you were actually aware of Mistral before coming to this? Not you. You're. Thank you. How do you think about languages? I mean, scripts. Do you use scripts in production?
Oh, yes.
Lots of scripts. I know. Okay. Any questions? Yes?
Why is it better than a programming language?
Why is it better than a programming language? Yes. this is a usual question, and I can tell you that in a programming language, in a usual program, I mean a standard programming language like C or Python or whatever, that is not giving you the pervasiveness that is required in the cloud or high availability. You are going to struggle with the high availability, with the monitoring aspects, with anything that is related to the distributed fashion that you have to execute your actions. And this is where Mistral is going to help you. It provides you an API, it provides you a description language, and it solves the execution of these operations in a distributed way.
So basically your question boils down to why is it a DSL domain-specific language rather than just programming, right?
No, if you are using Ansible for managing OpenStack, why don't you use Python for doing this? This is my question. But this is probably because I've never done this.
So, in my view, if it's programming, then from the operation side, it's something which is not so easy to comprehend for people who are actually doing operations. While a domain-specific language like this one is something where you can describe your wants to the system without having a functional or imperative programming environment, right? So actually, it's descriptive. Therefore, I think it's just easier to comprehend for the implement. But do you have any other ideas? I generally like this approach. Although I'm a programmer, I used to be.
Yes.
The other idea was to me to extend the Ansible to doing the same thing instead of implementing new kind of.
Yes, but how? Okay. Yeah, I think Red Hat is doing that actually with Tower and all the ecosystem that is built on Ansible. But I think Mistral is created for a different kind of domain. Ansible is usually used for provisioning your software. It is going to get the keys to your VMs. It's going to do whatever it wants, but it is going to have elevated, or the usual Ansible playbook requires elevated privileges, like pseudo rights and those kind of stuff. With Mistral, however, you have standard actions that you can execute, and these standard actions cannot be changed. So, but
those actions are really the domain of the workflow. With Ansible and the pseudo rights, you can just break the whole system. With this confined domain specific.
Yeah, it depends on you. For us, Mistral was a natural choice because we have experience with that. Of course, we use Ansible as well, but Ansible is usually just used by the integrators to execute their business logic. That is the custom action, actually. And the workflow is implemented as a Mistral action.
Any other questions?
Thank you very much.
If not, then I would just thank you very much again for coming here.